right, good morning. Happy Tuesday morning. Well, it's probably not Tuesday morning where you're at right now. So this is our last video notes for this week. We're looking at parameter changes of a new function. This function is called the square root function. So far we've looked at this year, we've looked at quadratic functions. Remember, a quadratic function makes a parabola. Okay, an absolute value function, when you have the absolute value, makes a v. So today we're going to look at a square root function. So the equation for the parent function of a square root function is y equals the square root of x. So let's make a table and graph this. First of all, you need to know, this is very, very important. You can't take the square root of a negative number. So the numbers we input for x need to be 0 or positive numbers. Okay? So we're going to go ahead and start off with 0. The square root of 0 is 0. Okay, 1. The square root of 1 is 1. 2. The square root of 2 is irrational, so I'm going to go ahead and stick with rational numbers here. Square root of 3, no, that's irrational. Square root of 4 is rational, so I'm going to go ahead and plug in 4. Square root of 4 is 2. The next rational number that I can get out is going to be 9. Square root of 9 is 3. Then 16. The square root of 16 is 4. And then I think we're off the graph here. So we're probably off the graph with this one as well. We could keep on going, 25, 36, 49, and get some more numbers here. But let's go ahead and graph this. So we have 0, 0. This is going to be our special point. Remember I talked to you about the special point? The special point on the absolute value being this point right here. The special point on a quadratic being its vertex. That's the point we're translating. Okay, so the special point for a square root function is right here. 1, 1, 4, 2, 1, 2, 3, 4, 1, 2, 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Alright, so it starts here as a starting point and it curves up and over, and you put an arrow on the end, and it goes on infinitely. Okay, so let's go ahead and move down here and look at parameter changes. So first of all, let me give you the equation with the parameter changes in them. So we're going to have y equals a times the square root of x minus h. Okay, I like to put a little tail because it closes there, plus k. K goes on the outside. The square root symbol is a grouping symbol. Okay, remember a is your vertical stretch and your vertical compression. If a is greater than 1, we have the stretch. If a is between -1 and +1, it's a compression. Left and right, up and down. Okay, so right off the bat, it says sketch a graph of each equation using a graphing calculator. You need to include at least 2 accurately plotted points on each square root graph, but please include more if they fit on the graph paper. So it says, so they give us this. So you should notice that this right away is the parent. So basically you're graphing the parent. You can do that. We just did that up here, so you're doing it again. Now we have an a value of -1. Okay, so what I suggest here is that you plot the parent. So 0, 0, 1, 1, 4, 2, 9, 3. It went off the graph a little bit, but the idea. Okay, so the A value is -1. Okay, so that means that, well, first of all, this point, instead of going over 1 and up 1, it's going to go over 1 and down 1. Remember, this is our special point. We don't go this way though, because that gets us into negative x values, and you cannot take the square root of a negative number. Okay, let's take a look at the next one. This one's right for up 2. So it's going to be right for down 2. See, the negative causes the square root function to reflect over the x-axis. So instead of going up a positive value, we're going to go down. Okay, so this would be over 9, down 3. Now these are affecting the y-coordinates. Notice the x's are staying the same. So we have a reflection, okay, over the x-axis. So this is very similar to, on moving the monster, taking a negative of the function. So negative of f of x. Okay, so try number 3, and okay, so let's look at some problems on the back. Here we have 3 times the square root of x. Okay, here's our function, square root of x. We're multiplying it times 3. So we're taking each y-coordinate and multiplying it by 3. So this is similar to 3 times f of x. Okay, so we're going to go 0 times 3, 0. Okay. Again, the best thing to do here is to put your parent on the graph, so that way you know what you're multiplying. 1, 1, 4, 2, 9, 3. It helps a lot. Otherwise, unless you can remember your y-coordinates. So 0 times 3, 0. 1 times 3, 3. 1, 2, 3. 2 times 3, 6. 1, 2, 3, 4, 5, 6. 9 times 3, a really big number. Alright, so this represents 3 times the square root of x. And this is a what? This is an a value. It's greater than 1. So we have a vertical stretch. Or you could say it's dilated by a scale factor of 3. Okay, let's take a look at this one here. This time the function is moving up 4 units. So another way of writing this would be f of x, that's the function, and we're moving the function up 4 units, just like I'm moving the monster. Here the function is moving 3 units to the right. Another way of writing this in function notation would be f of x minus 3. In this case, the function is the square root function, and the square root function is getting moved 3 units to the right. Okay, so let's go down here to number 9. Number 9, well, we do parentheses first, so we're going to move the square root function 2 units to the left, and then we're going to reflect it from there. Okay, so that's going to be a little bit of a challenge problem. I'm not going to go ahead and work this completely out for you. It's a pre-AP class. Hopefully you like challenges. Let's see if you can come up with that answer. Okay, you're welcome to work these problems, but I will give you time in class as usual to do this work. I think I'll stop there. Just remember that when you're translating, you're moving that special point. So in this case, it translates 2 to the right and 3 up. So that special point would translate 2 to the right, 1, 2, and 3 up. And then you would move all the parent function points. You would move them all. 2 to the right, 3 up. 2 to the right, 3 up. Okay? Alright. I know it says using a graphing calculator here, but you don't need it. If you know the points on your parent, you can transform them. Okay? See you tomorrow.